Let us consider a real-life application to demonstrate the utility and the challenges of big data. Many industries naturally deal with large amounts of data. For our discussion, we consider an energy company that provides gas and electricity to its consumers in an urban area. In this news report, you can see that Commonwealth Edison, or ConEd, the gas and electric provider of New York, decided to place smart meters all through its jurisdictions. That comes to 4.7 million smart meters. Now, smart meters are smart because aside from measuring energy consumption, they have a two-way communication capability between the meter and the central system at the gas and electric company. In other words, they generate real-time data from the meters to be stored and processed at the central facility. How much data? According to this report, the number of data received at the center is 1.5 billion per day. So the system will not only consume this data, but process it and produce output at 15-minute intervals and sometimes 5-minute intervals. Let's do the math. That comes to ingesting and processing about 10.5 million data points per 15 minutes. So what kind of computation must take place within these 15 minutes? Well, one obvious computation is billing, where one needs to compute who, especially in the commercial sector, who actually owns the meter and should be billed. This requires combining the meter data with the data in the customer database maintained by the company. But let's just consider computation related to analytics. We can list at least 4 different kinds of computations. The first is computing the consumption pattern per user, not per meter. Per user, where the output is a histogram of hourly usage. So the x-axis of the histogram is hourly intervals, and the y-axis is the number of units consumed. This needs to be computed both daily and over larger time periods to determine the hourly requirements for this consumer. The second computation relates to estimating the effect of outdoor temperature on the electricity consumption of each consumer. For those of you who are statistically inclined, this often involves fitting a piecewise linear regression model to the data. The third task is to extract the daily consumption trends that occur regardless of the outdoor temperature. This is again a statistical computation and may require something like a periodic autoregression algorithm for time series data. The algorithm is not that important here. What's more important is the ability to make good prediction has a direct economic impact because the company needs to buy energy from others. For example, an underprediction implies they will end up paying more for buying energy at the last moment to meet the consumer's requirements. The fourth task is to find groups of similar consumers based on their usage pattern so that the company can determine how many distinct groups of customers there are and design targeted energy-saving campaigns for each group. This requires finding similarities over a large number of time series data, which is a complex computation. Now, regardless of the number and complexity of computation required, the company is constrained by the fact that it has only 15 minutes to process the data before the next round of ingestion and computation has to be performed. Thus, the issue is not just the bigness of the data, but the strict constraint on the arrival to output time. The analytics has value only if it can be completed within the life cycle deadline. So if we were to design a big data system for such a company, we would need to understand how much of the computation can be executed in parallel and how many machines with what kind of capability are required to handle the data rate and the number and complexity of the analytical computations needed.